A second strategy I'd like to share is the area model for division. This one is actually really great. Students use an area model for multiplication. And if they can use it for multiplication, let's use that to our advantage and also teach it with division. So it's all about the area within this rectangle. It can be any size rectangle. I do at least try to make it somewhat appropriate that if the inside is represented by 1932, then I'm going to have over here off to the side 23 because I'm trying to find out how many groups of this 23 I need to fill in the entire 1932. So my 1932 is the inside of my entire rectangle. That's how much it needs to equal. We don't know how many are going to be up here or how many are in each group or how many groups of 23 that we have. Either language is good to use with this. Similar to the partial quotients, I can use chunks, parts of the quotient that I'm comfortable with, but now it's more of a visual area model instead. Another major difference, I don't have to subtract with either one, but I think this one's even more fitting to just do with think addition, and I'm adding up until I get to my final number that I'm trying to find. But you can also do it with subtraction. I'll show that off to the side that we can do either way. So I'm starting with the thinking of 23 or just about 20 times how much do I know confidently will stick within my 1932. All of this depends on the level of their number sense. Some kids might jump to 100. And then I have to ask myself, well, 20 times 100, 20 groups of 100 would be 2,000. That's too much. So we went too far. They can jump down and do a small group such as 10, but they need to think about that 20 times 10 is only going to get me to 200. That's not even close to the 900 that I need. So I'm going to stick with a lot of the simple ones, 1s, 2s, 5s, 10s, because that's very comfortable for the students. And since I do know that 2 times 5 is 10, I can figure out 20 times 50. So I can do 50 groups of 23. I'm going to draw a line. I'm going to have to guess. I think it'll be about that much of my product. Maybe not. 50 times 20 is 1,000. And 50 times 3 is 150. So off to the side, I'm going to keep a running tally. I've got 1,150 used up so far, but I'm still trying to get all the way to 1,900. The other option is to actually start a subtraction column and subtract that. I'm going to stick with the addition for right now because I think it makes it even more accessible to students. Well, I've only got 100 and I need 900, so I need to get close to another 800 somehow. Oh, I'm not so sure about 800, but let's do 20 times 20 because I know that 20 times 20 is 400 and 20 times 3 is 60. So I have 460. I'm going to add those together because that's everything inside my box or my rectangle so far. I have 1,610. Need to keep going, but now I really only need about 300 more to get close to 900. So 20 is too much. Let's just do 10. 20 times 10 is 200, and 10 times 3 is 30. I've added another 230 inside my rectangle, so I add that up. Ooh, I'm getting close. 1,840. Well, if I knew 10 was 230, 5 groups is going to be half as much, so that's 115. 115 is going to be too much because that's going to push me into 950 area. So I need to go less than 5. Maybe my brain wants to do 3. They could have done 2. It's whatever they're comfortable with. 20 times 3 is 60, and 3 times 3 is 9. So I'm going to add 69. I am too far. It's because I added incorrectly. Now 4 plus 6 is 10. Apologize for the simple mistake there. All I have left now is to get to 32, and that's not very far away. So I'm just going to do one group of 23. 1 times 20 is 20. 1 times 3 is 3. So if I add 23 and do my addition correctly this time, I made it. I'm back at 1,932. That's everything inside this box, but I solved it all straight through just the multiplication and using my number sense. Notice that when I multiplied by a larger value, a greater value, my box was a little bit larger, or sorry, it got smaller as my values were smaller. They could have started with a 1 way over here, but it's just going to be a really small line, and then they realize, oh, this is going to take forever. They could have tried 10 next. Doesn't have to be precise and exact with how big those boxes are, but we do want it to be somewhat relatable to the value of the number that they're going to get when they multiply. This one, I would start with a smaller value than 1,932. I just wanted to give you an example of how this works. If you have any questions, please let me know and I'd be sure to help. Be glad to help.